All right, let's look at derivatives of inverse trig functions. This is looking at a section where you're, again, more or less going to have to memorize if you want, but in the end, you can kind of get away with skipping it. I'll talk more about it in class if you have questions or want to kind of check in on that. So there's a bunch of inverse trig functions. You'll see them in your notes if you've got the prepared notes, or I'll just write them all out here. But it's basically finding the derivative of all of our standard functions. So the inverse sine of x, inverse cosine of x, inverse tangent of x. You'll also, if you remember, this is useful if you forgot, arc sine, arc tangent, arc cotangent, all the other things, that's the same as sine inverse. So the inverse sine of x is 1 over square root of 1 minus x squared. Inverse cosine is negative 1 over 1 minus the square root of x squared. I think I misspoke there, but you see it written correctly. The derivative of the remaining ones, cosecant of x is negative 1 over the absolute value of x, square root x squared minus 1. Secant to 1 over absolute value of x times the square root of x squared minus 1. And cotangent. Let's go to negative 1 over 1 plus. Now, all of these can be proven by using the inverse trig relationships. All the proofs are very similar, so I'm going to show one so that you've seen it. But at the end of the day, if you want to just memorize these, or quite honestly, if you want to just skip them for now and come back to them when it gets close to the AP exam time, you would probably be fine. It's a fairly minor point, but it is part of the curriculum, so I want to make sure we've covered it. All right, proof for arc sine. So we're starting with the fact that we want to find the derivative of inverse sine of x. This means that our inverse function we're calling inverse sine of x. That means our function is sine of x. So if I use my derivative rule, the derivative of f inverse of x is equal to 1 over f prime of f inverse of x. That means that if we look here, f prime of x will be cosine of x. So this is 1 over cosine of inverse sine of x. So now you might be saying, Mr. McKinnell, that doesn't look like what we solved before. And you are correct, it is not like what we wrote before, and that's because it's kind of ugly here, and there's a property we'll take advantage of that will clean this up. So if I know that sine of x is equal to, if I'm looking at inverse sine of x, then I'm going to have some function, that's going to be talking about some angle here on this triangle. So I'm just going to add the rest of these labels in. So if I have some angle where sine of theta is equal to x over 1, right? F of theta is equal to, or sine of theta I want to be equal to x. So that's why I get x over 1 here. Basically, because I want to be using this inverse sine of x, I want that to equal some angle. So inverse sine of x on this triangle, sine of x would be sine of theta equals x over 1. So when I invert it, I get back to this angle theta here. So cosine we know is equal to the adjacent over the hypotenuse. So it's going to be 1 over square root 1 minus x squared divided by 1. But because divided by 1 is exactly the same, I get this here. And that does look like what we have in our notes. Inverse cosine, inverse tangent, inverse secant, cosecant, cotangent all use kind of the same logic and or related to quotient rule. There's a bunch of ways you can justify it building on what we've done. But this shows where it comes from. Most of what you'll do with this lesson or with this topic is just either have the inverse, the derivatives memorized to be able to use that maybe along with the chain rule, or sometimes if you're finding the inverse at a specific point, then we might do inverse sine of x and kind of put the two values that were given here, solve for this third one, and kind of work through that way. But that is basically all we have with inverse trig functions.